Conductivity of intrinsic semiconductor. What you see is the band structure of semiconductor. There is a conduction band, valence band, and in between there is forbidden energy gap. So when electrons move from valence band to conduction band, it leaves behind the vacancy. That vacancy we call holes. So there are electrons in the conduction band and holes in the valence band. Therefore, current in semiconductor is due to holes and electrons. Current in semiconductor due to both holes and electrons. Therefore, total current is I is equals to IE plus IH. Here IE is current due to electrons and IH is current due to holes. Where in this the current is given by relation I equals to number of charge carrier into cross sectional area A into charge Q into drift velocity Vd. Therefore, IE, that is current due to electrons, would be N suffix E, charge carriers of electrons, that is number of electrons, into cross sectional area of semiconductor. Charge on electrons is E into Vd. This is the drift velocity of electrons, and IH is equals to NH, N suffix H, that is the number of charge carriers into cross sectional area into charge on holes is E, and this is Vd, that is the drift velocity of holes. So in above equation, Ne and NH, Ne and NH are number of electrons and holes respectively. Number of holes number of electrons and holes respectively. E is charge on electrons and holes. Charge for both is same. A cross sectional area of semiconductor. Vd is drift velocity of electrons and holes in particular direction. This drift velocity is nothing but average velocity of charge carriers in one direction. In particular direction. So this Vd would be equals to mu into E, where mu is the mobility and E is electric field. So Vd for electrons say is equals to mu E into E, and Vd for holes is equals to mu H into E. Here mu E and mu H are mobilities electrons and holes respectively. Okay, define the current density then. Current density J is nothing but current per unit area in particular direction. Current per unit area in particular direction. That is J equals to I upon A. That is equals to I plus IH upon A. Therefore, this J is equals to NE A charge, and Vd for electrons is mu E plus for holes NH, number of charge carriers, number of holes, cross sectional area A, charge is E, and the Vd is mu H into E divided by A. We can cancel A here, and therefore this J current density is equals to Ne mu E into capital E this Ne E mu E plus NH charge mobility of hole into E is equals to J. That is the current density. Then we can define the conductivity. Conductivity is denoted by the letter sigma, and that is nothing but current density per unit electric field. That is sigma is equals to current density is J, electric field is E. But we know the value of J. Substitute J here. So what you get is Ne into charge mu E into E plus NH charge mu H into E divided by E. Here also this E cancels, and what we get is sigma is equals to NE mu E plus NHE mu H. But in intrinsic semiconductor, this number of electrons is equals to number of holes, and that we are denoting by Ni. So this equation we can write as sigma is equals to Ni into E into bracket mu E plus mu H. So that is conductivity. Then let us substitute the value of Ni in above equation. We get sigma is equals to, then we know that Ni is 2 into 2 pi k upon s square raised to 3 by 2 into square root of me star mh star bracket raised to 3 by 2 t raised to 3 by 2. This is the value of Ni into e raised to minus of Eg upon twice kt. This is the value of Ni. So Ni I have substituted. In between there is E into mu E plus mu H. However, we know that the mobility is inversely proportional to t raised to 3 by 2. So mu E is inversely proportional to t raised to 3 by 2, that is equals to, say constant is alpha, t raised to minus of 3 by 2. Similarly, mu h mobility of holes is also inversely proportional to t raised to 3 by 2, that is beta into t raised to minus of 3 by 2. Therefore, this mu e plus mu h is equals to alpha plus beta raised to into t raised to minus 3 by 2. Let us substitute this in above equation and rewrite it. What we get is sigma is equals to 2 pi k upon h square raised to 3 by 2 into square root of me star mh star bracket raised to 3 by 2 into t raised to 3 by 2 into e, and this mu e plus mu h is equals to alpha plus beta into t raised to minus 3 by 2 into e raised to minus of Eg upon twice kt. So in this equation, this t cancels with this t. This is constant, this is constant, this term is also constant. So we can write sigma is equals to sigma naught e raised to minus of Eg upon twice kt. And this sigma naught is equals to this, 2 pi k pi s square raised to 3 by 2 square root of me star mh star bracket raised to 3 by 2 into e into alpha plus beta. So this is constant. And we got this relation sigma is equals to sigma naught e raised to minus of Eg upon twice kt. Let's take log on the both sides. What we get is ln of sigma is equals to minus of Eg upon twice Kt plus ln of sigma 0. So this is like y equals to mx plus c is a straight line. So if you plot a graph of ln of sigma versus 1 by t, you get the straight line and slope is equals to minus of Eg by twice k. From this you can find band gap.